Hello, thank you for checking out Mr. Ware's videos. And today we're looking at Intro to Inequalities and solving some inequalities. Let's take a look at this. Oh, hang on, let me get this out the way. All right, so let's begin. All right, first, Intro to Inequalities. Vocabulary. An inequality is a statement that can compare two qualities that may or may not be equal. Qualities begin being compared. Use one of the following signs: less than, greater than, less than or equal to, or greater than or equal to. And math always makes sense. Less than, you normally read from left to right, so the smaller n is lesser than the greater n. So less than. Over here, with this part being bigger, the greater part from the left is bigger than the part to the right. So it's greater than. Less than or equal to, greater than or equal to. All right. Here are some words that you hear in maybe some word problems or just in talking that means these particular symbols. So, for example, you've got less than, um, fewer than. That obviously means less than, right? So you use the less than sign. All right. Greater than or more than. That's going to be a greater than sign. Pretty simple. But here's some other words: less than or equal to. That's obvious. But at most might sound like you use greater than. But at most, meaning it gotta be no higher than that. The maximum, no more than. In these type of situations, you want to use less than or equal to. And then over here we got greater than or equal to, but at least, meaning it has to be more than at least this uh, at this height to ride the ride. So it's greater than or equal to that amount. The minimum, no less than, greater than or equal to. All right, here it says the directions are to translate the given phrase into an inequality using the keyword and above identify the solutions that make an inequality true. So here it says x is less than 7. X is less than 7. So what would you do? Well, you could easily go to here and see where it says less than and put x is less than 7. What solutions that make the inequality true? There's a number of them, but it wants you just to list a few, like 6, 5, and 4. Okay? All right, on number 2, it says x is more than 11. X is more than 11. Well, you can look here and see where it says more than, and then um, put x is greater than 11. See, greater than symbol. All right, so x is greater than 11. All right, and solutions that make the inequality true would be stuff like 12, 13, and 14, and so on, because they're greater than 11. All right, go ahead and pause the video here and see if you can use these phrases here to answer 3, 4, 5, and 6. All right, let's take a look at the answers. All right, here at most means less than or equal to. So 14, 13, 12, and 11. Notice how we include 14. No less, meaning it has to be either 20 or higher. So we include 20, 21, 22, 23. Use the greater than or equal to. At least, also a greater than or equal to. Now, I don't know why they put 7 when it says at least 30, but evidently it was supposed to be 30. But if you put 30 and then said 31, 32, 33. That's correct because they have 30 here, but for some reason they put 7. And this one, x is no more than 13. X is no more than 13, which means x is less than or equal to 13. Okay, so it's 13, 12, 11, and 10. All right, let's look at a few more problems. All right, some more information. Solving inequalities. Equations using inequalities. Solving inequalities is just like solving an equation with a key difference. If you're multiplying or dividing, only multiplying or dividing by a negative number, flip the inequality sign. Okay, you're going to flip the inequality sign. All right, so let's take a look at what that looks like. Oh, one more thing. In order to solve inequality in an equation for that matter, first you want to eliminate the constant term by adding a subtraction. And then second, eliminate the coefficient by dividing or multiplying by the reciprocal. And that works for two-step inequalities and equations. All right, so in this next example, what we want to do is it says flipping the inequality symbol. Look at the variable. If it's teamed up with a negative number, flip the inequality symbol. So it seems like what they want you to do is flip the inequality symbol at the beginning. I usually teach it to do it at the end, but either way, here they just want you to know or want you to figure out, do you need to flip it or do you need to leave it alone? So here it says if the variable is teamed up with a negative number, where's the variable at? You got x, okay? It's teamed up with a negative number, right? So you're going to flip the inequality. So you will circle that and just show the inequality sign being flipped. But I went ahead and worked it out. And like I said, and actually, there it is. Now it's completely worked out. So I went ahead and worked it all the way out and showed that you could divide by that negative number here, and you're going to flip the sign at the end. Over here on this one, the x is teamed up with a -3, right? So by the time we get to that part and we work that negative number here, you got to change the inequality sign. So on these next few problems, you don't need to work them out. All you need to do is just tell me, do you need to flip it or do you not? So go ahead and pause the video here and tell me between 1 through 8, which ones do you need to flip and which ones do you not? All right, let's take a look. All right, number one, the variable is teamed up with a positive number, so no. Here on number two, the variable is teamed up with a negative number, so yes. Number three, the variable's teamed up with a -4, so yes. When they say teamed up, they really mean multiplied divided by, okay? Here, the x is divided by 8, and it's not negative, so we leave that one alone. 5, positive 3 times b, leave it alone. Here, -6 times c, we change that one. 7, x divided by positive 6, we leave it alone. 8, x divided by -3, we swap that one. And that's it. That is some notes on inequality. I want to thank you for checking out Mr. Ware's videos. Have a nice day.